Greetings and welcome. We're taking a look at the binomial theorem and probability, and specifically at what are called binomial experiments, starting on page 878 of our text. So binomial experiments have a couple conditions. Your events have to be independent of one another. There has to be only two possible outcomes. It has to be the same experiment repeated multiple times. So a couple different requirements. And just to point out, our formula for binomial experiments, probability of some number correct, n successes, or r successes and n tries, I guess I'll say. Is going to equal combo of nr times the probability of success raised to the rth power times the probability of failure for an individual outcome to the n minus rth power. Right, so that's kind of the formula that we're working with for these, and sometimes we're using the formula multiple times in order to account for multiple possibilities. So let's say, let's look at problem 14 for this. So let's see, what do we know? It says Isabel carries lipstick tubes in a bag in her purse. The probability of pulling out the color she wants is 2/3. So S is equal to 2/3. Suppose she uses lipstick 4 times a day. So N is equal to 4. Find each probability. So for probability correct at least 3 times, probability at least 3 is going to be the same as the probability of exactly 3 and the probability of exactly 4, right? So other information we can gather, what's the probability of failure on any given try? 1/3, right? So we could get that by doing 1 subtract the 2/3. And in this case, r is equal to 3, and in this case, r is equal to 4, right? So this is going to equal combo for 3 times 2/3 to the 3rd power times 1/3 probability of failure raised to the 4 minus 3 power, right, or the first, plus combo for 4 times the 2/3 to the 4th power this time. We're expecting success every time of the 4 attempts, times 1/3 to the 0th power, because 4 minus 4 is 0. So just so you know, this n minus r, actually wait, maybe I'll ask you guys, what do you think n minus r represents in terms of the problem? Right, n minus r is the number of failed attempts, where r, right, was the number of successful attempts. All right, so that's why that is n minus r. So I think it makes sense to understand it from, right, kind of a logical perspective rather than just memorizing a formula. So combo 4/3 is 4, I believe. And now I'm just going to cube the top and bottom here. You could get decimals if you start plugging these into calculators, but I'm going to try to maintain fractions here. So 2 to the 3rd is 8, 3 to the 3rd is 27 times 1/3, plus combo 4/4. There's one way to get 4 objects when you're selecting 4 out of 4, right? So let's see, times 2 to the 4th is going to be 16, and 3 to the 4th I believe is 81, and then 1 to the 0th is 1, and 3 to the 0th is 1, so we actually don't even have to write that. So let's simplify this. 4 times 8 is 32. Let's see, 32 over 27 times 3 is 81sts, plus 16 81sts. So this is going to equal 32 plus 16, 48 81sts. And does that reduce? Yeah, wait. Is 3 going? Yeah, it does. 16/27, yeah. And is that the right answer? I hope so. Bing, 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 bing. And if you had done a non-fractional approach, you would have found that this is approximately 59.26% chance of getting at least 3 out of 4 times right. Right. So yeah, to avoid the decimals, the trick is you just have to sometimes right, use your properties of exponents and kind of deal with the fractions and multiply them and then add them. I think often we'll end up with common denominators here anyway if we don't reduce in advance, so that can kind of be nice as well. So that's that possibility. Was there another one of these particular questions you'd want me to try? Well, let's see. What does 15 mean? Probability of no more than 3 times correct. So probability no more than 3 times correct. All right, let's see if we can break this up into individual probabilities. Does that mean none correct is a success in this perspective? Right, that's less than 3 times correct. So probability of 0 correct would work. Is 1 correct okay in this? Yeah. Is 2 correct okay in this? Is 3 correct? Yeah, it can be 3. We just don't want more than 3. And 4 correct is not allowed in this particular wording. So that's one way I could set this up. So you would have had to do this formula 4 times, or notice this is everything but 4 correct. Is that correct? Is that correct? How is that an accurate interpretation? This is everything but 4 times, right? So I could actually set this up as, let's find the probability of 4 correct and subtract it from a 100% probability. And it didn't work for you? So you should just, well, let's see, what was the answer? 65 81sts? 0.802? Okay, so you got it right. So I just want to point out that you could do the formula 4 times here, or you could have done the formula once and saved ourselves quite a bit of work. Let's just do this. Why not? So that's going to be minus combo. Let's see. In this case, R was 4. Actually, wait. We already calculated this. Right? I already know what 4 correct was. That was 16/81, right? So 1 minus 16/81 is going to be, I'd have to multiply this by 81/81. So 81 minus 16, let's see if I can actually, so 71 minus 6, 65/81? Yeah, and that's what we had a moment ago. And that doesn't reduce. So I just want to point out between these two perspectives of setting it up, sometimes one is far easier than the others. So just be aware of that. Sometimes it's worth logically thinking of it 2 different ways to try to figure out which one's going to save you the most work. And that, by the way, was about 80.25% of the time, if you're wondering. All right, let's look at another problem. So here it says Mara guesses at all 10 questions on a true or false test. Find each probability. So okay, all right. Between N, R, S, and F, what do I currently know before I even read any of the further details? There's 10 questions, so there's 10 attempts. Right? Yeah, half of the time you're going to guess right, and half of the time you're going to guess wrong. Okay? Because there's exactly 2 possible outcomes, right? You're either right or wrong. All of these events are independent of one another. we can actually use the binomial theorem in combination with the probability here. So looking at these problems, 17, 18, 19, or 20, which one would you like me to attempt? 20. The one that's going to require the most work, I think. So probability of half correct, at least half correct, sorry. At least makes a big difference there in the work. So probability of at least half is the same as probability of 5 plus the probability of 6 plus the probability of 7 plus the probability of 8 plus the probability of 9 plus the probability of 10. Or, what's the other perspective? If I subtract the kind of opposite, or yeah, I guess opposite of the situation, right? That'd be probability of 0 plus probability of 1 correct plus probability of 2 correct plus probability of 3 correct plus probability of 4 correct. And I'd have to parenthesize that whole thing, I guess, there. So 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6. The second way is technically a little bit shorter, but not by much, really. So let's start calculating some of these. So probability of 0 would be combo 10 attempts, 0 right. You had a half chance to get them right, but you got them 0 of the time, and you had a probability of failure of a half, and you got it wrong all of the time. Probability 1 would be combo 10, 1, half to the first. Now, in this case, you might realize because the success and failures are exactly the same probability, that this is going to add to that right. I could add those exponents multiplying two things of the same base. That these parts are all going to be the same. It's all going to have to do with the combination that's going to actually change the outcome. So probability 2 would be combo 10, 2. That'd be a half to the second times a half to the eighth. Probability 3 is combo 10, 3. A half to the third times a half to the seventh. And then probability of 4 is combo 10, 4. A half to the fourth and a half to the sixth. Oh. Bam. So what I was pointing out is a half to the second times a half to the eighth is still a half to the 10th. And a half to the 0 is just 1. So what I would be interested in calculating is what is 1 to the 10th power? Well, that's 1. And what is 2 to the 10th power? I think that's 10 24. Yeah. So all of these are going to end up having the fraction 1 over 10 to the 24 in them somehow. And then the combination is what I'm going to have to multiply those by. That's going to really change them. So combo 10, 0 is 1. Combo 10, 1 is 10. Combo 10, 2, that's where I'm not as quick on the draw. It's 45. Let's see, combo 10, 3 is 120. And combo 10, 4 is 210. Which those two are permutations of one another. Interesting. So, so I think you guys can see that that's 1 over 1024, 10 over 1024, 45 over 1024. And I wouldn't want to reduce any of these because I'm going to have to add them in a second. And 210 over 20. 24? Sure. 20. So, bless you. Let's see. 210 plus 120 is 330, plus that would be 375, 385, 386 is what all that adds up to. Right, if I add them all up. But that is the probability of the opposite of the situation, or the inverse of the situation that I'm describing, right? So that is this probability. So I want to subtract that from 1. So 1 minus, or actually I'll just rewrite 1 as 1024 over 1024ths minus 386 1024ths. And I'll get 656 out of 1024 is the probability describing this situation, which reduces to 41/64ths, which is about 64.06% chance of success. And what situation were we describing again? At least half of them correct. At least half. So the probability of her, so if she just guesses on all of them, that's saying that she basically has a 64% chance of, let's see, wait a minute. Uh-oh. Guys, wait a minute. Let's see, 319 times 2 is 638. So why do I have too many? Pretty sure all of this checks out. I don't know. Did anyone else get my answer, or did anyone get the book's answer? Let's see, probability at least half correct was, right, 5 all the way to 10. Hmm. 319 out of 512. So they're saying 62.3% chance. Well, I don't see my error, so if anyone on the internet ends up spotting it, just add it to the comments. Maybe I'll have to add a little overlay to the video or something like that, an annotation or something. Well, anyways, but that's the idea. Thanks for watching, internet friends. Have a great day. Bye-bye.